Problem 4. Using a quadratic equation. Competition. From the time Mark Twain wrote The Celebrated Jumping Frog of Calaveras County in 1865, frog jumping competitions have been growing in popularity. The graph shows a function modeling the height of one frog's jump, where x is the distance, in feet, from the jump start. So note the frog. The path of its jump is parabolic. And our quadratic function is shown here in the screenshot of a graphing calculator. Y sub 1 equals negative 0.029x squared plus 0.59x. First, part A. How far did the frog jump? Well, the height of the jump is 0 at the start and the end of the jump. So if we find the zeros of the function, the distance between those zeros horizontally, or difference in x's, will be the distance of the jump. So we can use the graphing calculator to find the zeros of the related function y equals negative 0.029x squared plus 0.59x. So we graph that function and we note the parabola. Here we have a point of takeoff where the frog's jump was initiated. We have a portion of the parabola that represents the frog's path while it was in the air, and then our second zero is where the frog landed at the end of its jump. Now notice the parabolic model, or the parabola graphed here, does include values below the x-axis, so negative values. But nothing past the second zero has real-world meaning, because the frog's not jumping into soft earth and leaving a giant impact crater, so it's not going below ground level. So, more carefully looking at our zeros, x equals 0 at takeoff, and x equals 20.34 at landing. So we can state the frog jumped about 20.34 feet. Incredible. Part B. How high did the frog jump? Well, the maximum height of the jump is the maximum value of the function, so its vertex value. This occurs midway at 10.17. Notice that's half of 20.34, the total distance. So again, at 10.17 feet from the start. Our job then is to find y for x equals 10.17. We substitute 10.17 for x into our function. Y equals negative 0.029 times 10.17 squared plus 0.59 times 10.17, and that's approximately 3.0. So we can state the frog jumped to a height of about 3 feet. Part C asks, what is a reasonable domain and range for such a frog jumping function? Well, while the function y equals negative 0.029x squared plus 0.59x has a domain of all real numbers, actual frog jumping does not allow negative values unless we have a giant impact crater. So a reasonable domain for frog jumping distances is 0 is less than or equal to x, which is less than or equal to 30. A reasonable range is 0 is less than or equal to y is less than or equal to 5. Your turn. The function y equals negative 0.03x squared plus 1.60x models the path of a kicked soccer ball. The height is y, the distance is x, and the units are meters. How far does the soccer ball travel? How high does the soccer ball go? Describe a reasonable domain and range for the function.